Now, so today I will introduce a twist in it. There can be some of the topologies where there is no bolt at all. There cannot be any bolt. For now, you heard it and now you forget it. Okay. So by default, if you are creating the topologies by yourself, then you will be having the spouts and bolts with you. So now bolts, as it typically what it does is, the sole purpose for it is to consume the input streams, basically tuple input streams, perform whatever business logic. So today I'll be showing you 1 plus 1, 2 examples, okay, wherein I would be showing you end-to-end flow, and we'll be seeing that how exactly you generally implement your business logic. But now guys, the overall purpose for these examples, which I'm going to demonstrate within the class, is to show you the flow, how it goes, how to put it together, and I have written the basic minimal business logic. So let's say if I have some decision point, I have by default written true. But tomorrow, whether you want to return true or false kind of thing, right? You can write your own business logic in those places, right? So those kind of things, we'll see that today. So bolts, clearly, they are going to consume the tuples, apply the logic, and last line, that last part of sentence is equally important, and potentially can, introduce new streams, or potentially can emit the tuples. So when I say potentially, probably if this is your end bolt, right? End bolt means you have a stream. So spout, bolt, bolt. Let's say you have a spout, under bolt, and end of topology. So the last bolt probably might be persisting it, or might just be creating an event and pushing it in some other queue altogether, right? This might also be the end result. So in that case, the end bolt is not supposed to create more tuples, right? So that is why it is written as potentially. So a bolt can produce the further tuples, or might choose not to even not to produce the tuples. Okay, guys, is the statement and the is everybody clear about the meaning of the statement and all, right? The purpose of bolt clear to everybody? May I just take it as a checkpoint? Venkat, yes, you have a question. Just a second. Okay, great. So Venkat has a question. Setting number of workers, how does it work in a distributed cluster? If I set 3 JVMs, we'll start a JVM in each supervisor, or all the 3 workers in a single supervisor. No. These 3 JVMs would be there in 3 different supervisors themselves. It would not be within a single supervisor. And their states are being shared via zookeeper. Okay, Venkat, clear, right? Next is by Sundar. Can the spout and bolt be running on different machines? They can be running on different machines, no, not a problem. So they need not to be co-located. In fact, you can't even tell, Sundar. You can't even tell. So the worker has the JVM. Yes. So see, worker is a process which would be running inside the JVM, right? So you saw that, right? Node, within that node, the worker, it was running within a JVM itself. Worker is what? Is this a process? Right? Vishnu? And the executors, those executors, right? When it comes to, let's say, either the spout or the bolts, they would be running as the different threads within the JVM. Right? Vishnu? Okay, so Sundar says okay. Correct. So you can, exactly. So it's like JVM is the container for the worker thing. Within the workers, you can have, various executors. So spouts, bolts, etc. I mean, not etc. Basically these two. Etc. comes when Trident would come into picture. So how does the communication happen between the threads when they run in different JVM? This exactly is where Storm will come into picture. You will see some of those cases. It has its own kind of data structures. Okay, we'll see. By the way, so, typically, let's say you use something called integer, right? So you typically need the integer. Probably if we have to increase, let's say, some sort of transaction count or some sort of transaction ID itself, instead of integer, what is its concurrent equivalent? Anybody from Java background? What is the equivalent, concurrency equivalent of integer wrapper class? Atomic int, right? Atomic integer. No, concurrence, Venkat. Concurrent equivalent of integer, that is atomic integer. So we'll be using atomic integer probably, right? So those are the basic things which you have to think about. Now Gopa says, since Bolt is able to read from streams, okay, fine. Why do we need spout? Okay. Gopa, what I would say is, see, these both of them are just a different, at the end of the day, they are simple Java programs altogether. Now, Spout has a different implementation, class implementation altogether, kind of messages which are there are different, whereas when it comes to the bolts and all, right, bolts may do, like, they just take the data, they can perform some sort of aggregation logic, as you will see. Just a second, hold on. I think so. Gopal, hold on this question. Probably the very next slide may give you the answer. Just a sec. Okay, so bolts may subscribe to the various streams which are emitted. They could be emitted by the spouts, or they could be emitted by the bolts themselves, and then they can perform the business logics on them. And the kind of business logics which you can do is probably these kind of functions, like I mean, any kind of processing first of all, but the kind of functions which you can typically do is filtering of the tuples, joining and aggregation, calculations. Your database reads and writes. It is written at last. You can do it, but typically we do not suggest it unless your databases are like your NoSQL kind of databases and other stuff which support very high throughput kind of thing. Okay, for a POC project, probably you can integrate it with some sort of MySQL or SQL, sorry, Oracle kind of databases, right? It's a simple Java program, so JDBC connectivity, of course you can do that, but in a typical big environment, right, in the production environment and all, probably MySQL would not be really a very good strategy. You would like to connect to, let's say, HBase or something for the persistence, right? So Gopa, this is where the answer of your question comes. Your I would say your spout and all, they basically do not facilitate for any operation other than filtering. The best thing which you can do within a spout is, because you get one record at a time there, okay, Gopa? You can just get one record at a time. You cannot really keep the state there. You cannot keep them together and do any kind of aggregation kind of a logic. Okay, so if you are saying, if you just want to do some sort of I would say record transformation only, probably you can do that. Another viewpoint is Spout, you just need a guy who just, let's say, takes the data, does a bit of data messaging if required, and then just sends it, right? Because that would be the single point of entry, right? You need somebody to connect to the external hook, right? Once it brings up the data there within the system, then depending upon what kind of grouping you are using, you remember stream grouping, you can send required kind of, I mean, different kind of tuples to different kind of, let's say, bolts altogether for business processing, because your business processing might not be just a single business processing, right? Gopa? So this is more of a logical, distinction rather than a technical distinction as such. Okay, Gopa, I'm waiting for a response. If you still have the question. Okay, sure. Thanks, Gopa. Not a problem. Now, just like we saw some of the methods, sorry. So we did see some of the methods in Spout. Similarly, when it comes to the bolts, typically you will, in fact, all of the examples which I'll cover, you will see base-rich bolt, okay, which basically implements the I-rich bolt here. Now, some of you might be thinking, what is I-rich bolt? What is base-rich bolt and all? For that matter, see, it's just like your Java APIs and all, right? So these are the different classes, different interfaces, hierarchies and all. What I would really suggest all of you who are at least from Java background, you can just search for this I-rich spout and then called I-rich bolt, okay? And then just yes, I-rich bolt and I-rich spout, and then just search for the kind of methods which it has, because I could have taken the screenshot of it and given it to you, but it doesn't add any value, right? It is either I take the screenshot and put it to you, or it's just a class hierarchy. This is how it is designed. This is how the API is designed, and there are various kinds of bolts for almost all of the purposes. The base-rich spout, fulfills all of your purposes, but there might be some of the cases, let's say, wherein you might be writing your spouts and bolts in some other languages. Let's say you are writing your spouts and bolts in Clojure. Clojure is a language, okay? So there are some specific spouts designed for it. You were getting the idea, right, Arpan? Because you are from Java background. Sundar, Gopa, Niranjan, I mean all of you, right? See, the whole idea is the root spout and bolts are I-rich spout and I-rich spout and I-rich bolt. Under that there is a whole class hierarchy. The most useful, or I would say in 99% or probably 95% of cases, you will be using base-rich bolt and base-rich spout, okay? Now what you would be having is it would just be implementing these particular functions, okay? Declare output fields, prepare, execute, and clean up, okay? So I'll tell you one by one, although the names themselves are quite clear, right? So prepare. Now the prepare is a method. Just a second. Seems like Arpan says yes. Arpan, yes. Answer of your question is yes. Okay. So I'm just continuing. Okay. Now coming back to this, so there are methods: declare output fields, prepare, execute, and clean up. Okay. So when it comes to prepare is just like you remember in it there was a method, right? It was called one time. Similarly, here also you have a method called prepare. This would be called just before the processing of the tuples start, and it is again just like in it. It has all the logic, or you will implement all of the logic to do one set activity. Okay, one setup of one-time activity kind of thing. So the best example is, let's say, getting some database connections, right? So yes, exactly. So getting some database connections, setting up some properties, setting up some constants altogether, right? Probably when you say constant, probably there are two ways of defining the constants, right? Either you define the constant within the class, right? If you are reasonably sure that it is never gonna change, or you might be getting those constants again from a, let's say, from a configuration file, right? So every time when you run it, so before the executor starts running it, or I would say bolt starts its processing, you would like to see the configuration itself, right? So that is something which would be that kind of logic would be written in prepare. Now my next question is how many times do you think prepare would be called? Once in a lifetime of entire bolt life cycle. That is why I'm writing it as life cycle. Okay, guys, is that clear? Life cycle, clear cut. It runs only one time. So what I mean by that is, once you deploy the topology, right? As soon as you deploy the topology, your threads are going to start, right? The threads for for bolt as well as for spout, they're gonna start. At that time, prepare method would be called, and all of the necessary connections and all would be made at that point of time. Next point would be after prepare, execute. Now all of your business logic, whatever is your business logic, guys, is gonna be written in execute. Is that clear? Execute is the one where you will be writing your business logic. So these are the very important placeholders, guys. You know, I'll show you the logic and all, but the thing is you should know the importance of it, because business logic is something which is gonna change tomorrow for you. But these placeholders are never going to change till the time you are working, let's say, on a reasonably near range of Storm range, you know, Storm version. Because the Storm itself is undergoing some changes. I don't know whether 1 year down the line the same APIs will be applicable, right? But as of now, they hold good, right? So execute would be the one. Now, my question to all of you is, how many times do you think it would be called? It would be called as soon as any new tuple arrives, right? It would be called, right? Guys, everybody understands it, right? So just like next tuple, you remember, as soon as the next tuple was called, effectively whatever number of times next tuple was called, I cannot give the formula that if next tuple was called 10 times, then execute also will be called 10 times. No. Okay? No. Why? Any reason behind it? Why cannot we establish this formula? Reason is, assuming that everything is working properly, right? You remember in the spout, you can apply a bit of filter logic, right? So a tuple came or a record came, you decided right away this is you know, some garbage. So your next tuple was called, but your executor would not be called, right? Sorry, execute function would not be called. Now comes the declare output fields and the cleanup part. Now, declare output fields is the guy where you declare the output schema of the bolt. Means the bolt, when it takes the you know, data, whatever are the fields which it is emitting, it needs to declare all of them. So just like you had the reliability feature, right? At the spout level, of course, the same reliability feature would come at the bolt level also. It comes with a catch. Okay, I mean everything comes with a catch only, but still the catch here is that if you have implemented the reliable spout, okay, then you have to implement reliable bolts. Okay, is that not clear? If you have implemented reliable spouts, then you have to implement the reliable bolts also. Reason, because the reason is, if you have implemented the reliable spout, then it is following an acknowledgement and fail mechanism. You remember? And if it gets the acknowledgement, then it does something. If it gets a failure, then it does something else, right? Now the point is, how does it happen? So you have written the acknowledgement and fail logic. That's fine. But somebody needs to send it a signal, right? That, hey, I have acknowledged it. Hey, I have, you know, this has failed for me, right? You need to do something. So if you have implemented acknowledgement and fail, but if you have not implemented acknowledgement and failure in the bolts, then by default it will never ever get the acknowledgement methods, right? It will always assume that the tuple processing has failed. Then all the time your failure method would be implemented or would be called again and again, again and again.